Welcome to the Healthcare Workflow Process Improvement Process Diagrams. This is Lecture A. This unit is composed of several lectures, one for each diagramming method. Lecture A, Process Diagrams, provides an introduction to these concepts and reviews information from Unit 2, Lecture B. Based on feedback from practitioners, we recommend using two methods: data flow diagrams in Jordan notation and flowcharts. In Lecture A, we review the process aspects that each diagram type covers. In separate presentations, we cover each diagram type. For the two recommended methods, the presentation covers concepts and skills from reading and interpreting the diagrams to actually creating them. For the rest of the diagrams, we cover only background, use, and notation, i.e., the presentation prepares the student to read and interpret the diagram, but not to create them. The objectives for this lecture are to create a process flowchart for a healthcare system or system component using appropriate ISO 5807 symbols and conventions. Create context and data flow diagrams for a healthcare system or system component using appropriate Jordan symbols and conventions. Choose the correct scope and detail level for a process flowchart and data flow diagram. Read and interpret Gain-Sarson data flow diagram. Read and interpret an entity relationship diagram in crow's foot notation. And read and interpret UML class, activity, and state diagrams. The topics covered in this lecture include key process aspects that may require analysis and diagramming, types of process diagrams. In Lecture A, these topics are combined into a framework that organizes process diagram types according to the process aspects that each type of diagram represents. Thus, Lecture A serves as an introduction to the Unit 3 material. There are different kinds of process diagrams. They differ in the aspects of processes they represent and in the notations, i.e., symbols and conventions used for diagramming or mapping processes. The types of diagrams covered in this unit include ISO 5807 information processing diagrams, the same symbols used for flowcharting, Jordan notation for data flow diagrams, Gain-Sarson notation for data flow diagrams, Unified Modeling Language, UML, that represents several different aspects of processes, and Entity Relationship, ER diagrams that concentrate solely on information content. We will review the process aspects that each diagram covers and show an example of each type of diagram. This lecture provides a brief introduction and overview to process aspects. For example, informational versus process steps, etc., that are covered by each diagram type. This brief introduction serves as a framework to help you organize the different diagramming notations according to which process aspects they cover. Later, this framework will serve as a reference when choosing which type of diagram best fits a process improvement need. The process aspects to be featured will determine the type of diagram to be used, i.e., the diagram that best represents the process aspects that you are interested in. The 6 important process aspects are context, process steps, information flow, information content, information transformation, sequence, and other control, who or what role performs the step. Unfortunately, the words used to describe the process aspects have different connotations and even meanings in different disciplines. Briefly, by context, we mean how a system or process interacts with the rest of the world. For example, a context diagram is used to view the system in the context in which it operates. Context diagrams show main system components and the ways in which the system interacts with things outside of the system. For example, inputs and outputs. By process steps, we mean the physical and mental tasks or activities that are involved in a process. We separate diagramming these physical and mental steps from data flow. Here, data flow means the path through which data and information travel. Data flow is the process from the data's perspective. Process flow is usually the process from, for example, the patient or provider's perspective. Information content refers to the pieces of data, information required for process, or informational steps or decisions. Data and information transformation refers to manipulations performed on data. For example, calculating age from a patient's date of birth and today's date. Step sequence, flow control, and state or status all refer to the order in which data or things move through a process, and the logic that controls that flow. And finally, roles refer to who or what performs the process steps. The following table in the next slide indicates which process aspects are covered by the notations, diagramming methods. Note: the healthcare setting in which you work may have standardized on one particular notation, method for their process representation. Further, healthcare facilities may have participated in quality improvement or software development efforts, in which case there may be existing process diagrams that may be of use to you. So while you may prefer a particular method and can select that method of use in this course, it is important to be aware of the major notations, methodologies, and to understand the basic uses and notation of each. This unit covers 5 notations that are commonly used to diagram processes: ISO 5807, Jordan, Gaines-Sarson, UML, and ER diagrams. ISO 5807 can be used to represent process or data flow steps and their sequence and control, as well as information transformation and roles involved in the process. Jordan data flow diagrams represent context, data flow steps, and information transformation. In Jordan diagrams, information content is captured through text, but not captured in structured form. Gaines-Sarson represents the same process aspects as Jordan, with the addition of capturing flow control and state in text. Unified Modeling Language, or UML, developed a few decades after and heavily influenced by the earlier methods, was designed to represent important aspects of system functionality. The entity relationship diagram is designed to represent only information content. Supplemental material for this unit will cover each of these 5 methodologies. Not all of the process aspects noted earlier are critical for clinical workflow analysis and process redesign. For our work here, we concentrate on the following: Jordan data flow diagrams for context diagrams, ISO 5807 flowcharts for process steps and step sequence and control, as well as roles performing steps. Jordan context diagrams and ISO 5807 flowcharts are covered in this unit in Lectures B and C. Detailed instructions are provided on how to create and use these diagrams. Some organizations use these diagrams, while others use UML. From the examples received from the regional extension centers and available on the AHRQ and Clinical Quality Improvement websites, it appears that flowcharts and context diagrams are the most common in healthcare workflow analysis and process redesign, and thus we concentrate on these diagrams here. Because you may encounter other notations, for example, Gaines-Sarson, UML, and logical data models, ER diagrams, we provide exposure to those diagrams as well. Your instructor will pick and choose from the available material to best prepare you for local applications. The goal of workflow analysis and process redesign is to represent aspects of the process that help the analyst and healthcare facility staff identify areas where the process can be improved. The diagrams here meet this need by concentrating on process steps, data flow, roles, and visualizing the whole. There are other process aspects that are not critical to this analysis and thus will not be considered. Other efforts where the methods here have been used to successfully analyze and redesign healthcare processes include the Public Health Institute's Business Process Analysis and Redesign Program to improve the performance of the U.S. public health system. The Public Health Institute, PHI 2006 reference, provides great case studies and we recommend it. This concludes Lecture A, Process Diagrams. You should be able to understand key process aspects that may need to be diagrammed, Suggest a diagram type for a given process aspect to be represented.